Hey guys, Dr. Brown here, and tonight we're going to be looking at volume. I've had many people that sent word about they need a little bit more help on some volume problems, so here's a pretty good one. So nothing crazy, okay? We have a function, y equals natural log of x, and we're looking at that function from x equals 1 to x equals e, and we're going to rotate that about the y-axis. Okay, now you know there's two methods. There's the shell method and the disk method. Let's start, we'll work both of them. Okay, let's start with the shell method first. Okay, we can differentiate on x with that one, at least on this problem. Okay, it says I'm going to set up a differential rectangle parallel to the axis I'm rotating around. Okay, so in this case, since we're rotating around y, you can see this guy is parallel to that. Now that formula for the volume of the shell method is 2 pi times the integral, in this case since we're integrating on x, from a to b ph dx. And p is the distance the center of my differential rectangle is from the axis I'm rotating around. So this would be p, which is what? It's just x in this case. So I have volume equals 2 pi, the integral from 1 to e of x, okay, that's p. H is the height of my differential rectangle, and in this case it's just y, correct? Okay, and y, what is y? Y is natural log of x. And I'm differentiating that with respect to x. Okay, well, I could use the DI method here for integration by parts. Okay, I'm going to let my piece that I'm differentiating be natural log x. I'm integrating x dx. Okay. And derivative of natural log x is 1 over x dx. Integral of x, we increase that by 1, that's to the first power. x1 plus 1 is 2, divided by 2, I have 1/2 x squared. Okay, so now I have my volume equals 2 pi times 1/2 x squared times natural log x minus the integral, I'll write it here, the integral, that's minus the integral of 1/2 x squared times this. So I'm integrating this entire row. So 1/2 x squared over x is 1/2 x. X squared divided by x, x. There's a negative there. So minus the integral of 1/2 integral of x dx. Okay, so as x to the first power, increase that by 1, that equals 2 divided by 2. So volume equals 2 pi 1/2 x squared natural log x, and that's 1/4 now, minus 1/4 x squared. And all of that is from 1 to e. So nothing magical so far. Okay, my volume now is 2 pi times this guy here. So I have 1/2 e squared natural log of e, which is 1. So that's 1. Minus 1/4 e squared minus, now if I put 1 in here, natural log of 1 is 0, minus 1/4 1 squared is just 1/4. Okay, and all of that's times 2 pi. So volume is 2 pi times what? So now we have the, let's see, we need a common denominator. 1/2 is what? 2/4. 2/4 e squared. 2/4 of something minus 1/4 of the same something leaves me just 1/4 e to the second power minus a minus, which is plus 1/4. I'm going to factor out the 1/4. So I have 2 pi times 1/4 e squared plus 1. Okay, and then 2 over 4 is 1/2. So I have 1/2 pi times parentheses of e squared plus 1. That is my volume. I'm going to write that up here somewhere. So my volume in that method was 1/2 pi times e squared plus 1. All right, that was the shell method. So let's use the disk method now. Now within the disk method, we have to set up a differential rectangle. Okay, hopefully I can draw this, looks sort of the same. From 1 to e. This is my y value, that is x. But in the shell it says, okay, since you're rotating around the y-axis, I need to set up my differential rectangle perpendicular to the axis I'm rotating around. Now, you'll notice in this one, for a given value of x, we were looking at different values of y. And this one, for a given value of y, we're looking at various values of x, because I'm now would be differentiating on y. And if you're like me, sometimes when I'm differentiating on y, I'm turning my head trying to figure that out. But we need various values of y, or various values of x given a value of y. So let's solve for x. If I take e to the y, that's e to the natural log of x. All I did was raise both sides to e. Well, e to the natural log of x is what? That is x. So x equals e to the y. So now, the volume relative to the disk method says, I'm going to multiply this thing by pi. Now I'm multiplying on, obviously in this case, on y, so I'm integrating from c to d, and I'm integrating with my outer radius squared minus the inner radius squared dy. Now if we were rotating around the x-axis, obviously we would be doing other, this would be perpendicular here and rotating around. So, but we're not. We're rotating around y. We're perpendicular to the axis we're rotating around. But we're integrating from what to what? Well, when x equals 1, if x equals 1, e to the 0 equals, if x equals 1, if x equals 1, e to the 0 is 1. So y would be 0. So now we're integrating from 0. When x equals e, that's e to the first power, isn't it? So y would have to equal 1. So we're integrating from 0 to 1 of my outer radius. So I'm rotating around. What is my outer radius? It's e. So I'm integrating e squared. So e squared. My inner radius is what? My inner radius here would be here. It could be there. So my inner radius is really just x. Oh no, but what is x? X is e to the y. Hey. e to the y. I almost messed up there. So now it's e to the y squared, which you know your rules of exponents, that's e to the 2y. Now then, I'm going to integrate this thing, and I'm going to break it into two integrals because I usually mess up if I don't. So e squared dy minus pi times the integral from 0 to 1 of e to the 2y dy. Now in this case, e squared is just a constant, so I end up with pi times e squared y from 0 to 1 minus pi. Now, let's let u equal 2y, because I know the integral of e to the u du is e to the u. So u is 2y, du equals 2 dy, du over 2 equals dy. So I have the integral 1/2 the integral 0 to 1 of e to the u du. And that's the over 2 here. So what does all of this give me? Now I'm going to pull the pi out of both of these. I have e squared y minus 1/2 e to the u, and u was 2y, e to the 2y, and all of this is from 0 to 1. All right, so pi times e squared times 1 minus 1/2 e to the 2 times 1 minus 0 minus 1/2 e to the 0, which is just 1. So I have pi times, can you still see that, pi? All right, I have e squared minus 1/2 e squared, so 1 of something minus half of something gives me 1/2 of that same something, minus a minus, which is plus 1/2. So now I'm going to factor the 1/2 out, so I have 1/2 pi times e squared plus 1. It's 1/2 pi e squared plus 1, 1/2 pi e squared plus 1. So whether I use the disk method or I use the shell method, I can get the same thing. But I would encourage you to practice each method, okay? Sorry I'm sweating, it's hot here in the Philippines. Okay, why are we doing this? Hey, together we're trying to build a better tomorrow and do that through math. Keep studying, guys. That's all for now, and we'll talk to you next time. Thanks.